Welcome back. Welcome to another week of Unreal Behavior Trees. So in the last week, we got this guy kind of sort of pacing back and forth to me and to and back to that like spot over there. There's something that's really bothering me, which is that we have this hack in here, which is awful. Specifically this stuff and all this crap. In a real game, rarely, not all, often you don't grab the player like this. In a real game, what you're usually doing is you're trying to use senses and stuff to get the player. So let's start the framework of that. And in order to do that, at least in a good way, we need to be able to do stuff over time, and we don't really have that ability. Tasks are kind of one-shots. Some of them, like these waits and move tos, can sort of sleep, and all that, and you can be in that state until you get that callback, but you can't, like, they're mostly one-shots, and the ones that you write yourselves are mostly one-shots. What we want to do is we want to, no matter what's going on, periodically do something. And I mean, you can go here into, like, agent and, add some, like, update code, but you don't want to do that. You don't want to spread your code everywhere. It's also nowhere near as efficient as what I'm about to show you. So if I go back to our list of cool stuff, and I'm kind of running out of room here, I'm going to add another one. This may be the last one. And I'm going to erase some of this stuff just so I have a little more room. So what I want to go over now is the concept of services. Services do stuff periodically. That's kind of it. Probably I should have some symbol for services. Why don't I make it like a little hex node? That seems fun. All the service is a piece of code that runs every now and then. That's all it is. Specifically, if any node, here's our little tree, if any node is active, meaning that something below it is running, then that service will be updating as well. So for our case, what we're going to do is we want to inject something right here, specifically around this node, that says find the player. That's what we want to do. Because remember, you can lose the player as well. There's all sorts of stuff, right? You can find the player, lose the player, whatever. We're actually going to change some of this stuff as well. So, what I'm going to do, I'll just do it all here. Is player close? This is going to go away. We're going to replace this with, do we have a target? We're going to replace this guy with do we have a target? Everything else is going to be basically the same. As long as we have a target, we will go find the player and basically follow them. If we don't have a target, we will go to our position and wait. That's our new behavior. That's what we want to do right now. So we're going to have to change a bunch of stuff. We're going to delete this guy. We're going to go to this selector and we're going to create a new thing called a service. And there's a few services. They only have a couple. In other words, we're sort of screwed. We have to write our own if we're going to use a service, which makes sense. So let's go to content browser and we're going to write our own service. And I'm just going to, it's the same thing. We want to do a blueprint class. We want to search for service. We want to do the blueprint one. For those of you who want to play around in the C++ one, you inherit from BT service in C++ code. But for our purposes, BT service blueprint base select. And I'm going to call this, find player. Now I could name it like this. The architect in me says maybe we call it find target. That seems better. We open it up and here's our thing. So again, there's some overrides. And in Unreal, you're basically always overriding stuff in blueprints. In our case, we want receive tick AI. And so this is our our sort of AI tick that we're gonna get. It's basically every half second or so. It depends on what you set it to. So this is just like any other node. We can kind of do what we want and figure out what we want here. And I can do a lot of stuff. I'm gonna start super simple. What's the easiest way? How about a sphere overlap actors? That seems fun. So sphere overlap actors, I'm going to say controlled pawn, get actor, location, get actor location. So we're going to center it here. We're going to give it a radius of, call it 500. And I want to actively search for my one class. There's other ways that we can do it. We don't need to ignore anybody. This should do it. I don't remember if I actually need this. I think I'm gonna add it anyway. Make array. Because I basically want pawns. I honestly don't remember if I actually need this for this guy. That should be it. We could set tuning, all this stuff, but I'm kind of going fast for this stuff. Like normally you'd have this, I'll just do it. Because normally you'd have this kind of thing be tuning, right? So you'd go here and you'd say radius, and you'd make this like tunable and all this other stuff and default. And then here you'd set the default to 500, which I've already done, and so on. So these are all the actors that we hit. We'll make this more robust. I really just want to show you the concept of a service first, and then we'll get into some of the more complicated stuff. Out actors is this guy. This is going to be get. So what I actually think I want is I want some kind of like if statement here. And this is going to say probably length greater than 0. So what this is going to do is it's going to do a sphere test to see if I overlap anyone. If I do, I'll have more than one here. So this is the yes case. If I do, what I'm going to do is I'm going to say set blackboard value object. And here's where, we got to do the keys and all this other crap. This is where keys are kind of better, because what this key lets me do, it's going to work like the other blueprints. You'll see how this works. So here I'm going to say, target. That should be fine. The asset that we're going to set it to is, we'll pull this guy and we'll do a get. And we'll just grab the first one. And again, we'll do a more robust version of this a little later. I'm hoping that this part is super easy. And we'll pull this guy up here. So let's comment this a little bit so it's a little easier to look at. This is going to be our sphere test. That's this guy. And I'll pull this guy back. Then what we're going to basically do here is we're going to say, did we find anyone? That's all this is saying. And so if we did, then we want to set this blackboard value. And so then that's kind of it. We need to do the false case. I do want to do this. We want to set this to null. And so that's what this kind of, if I just leave this empty, it'll blank it out. So the hope here is that, here it's like found someone, so set the target. Can't find anyone, so clear the target. Okay, So if I just pull this out and we can see kind of the high level, these are the things that we're going to do. Let's zoom in. We want to do a sphere test. And if we can and gate it on this actor, which is the player. So if we can find the player within this sphere, great. If we found someone, this is our test, then we'll set the target. Otherwise, we'll clear the target. That's it. That's the service. We want this to just be constantly running for the most part. So that's our thing. So now I can go here to this selector and I can say add service and I can say find target, our new thing. Dink. Now here's where I was kind of talking about the timing. So here's our radius. Here's the description stuff. Here it is, interval. This has an interval of half a second with a random deviation of 0.1. So about from every 0.4 to 0.6 seconds, so every approximately half second, it's going to run this. Why not just be every 0.5? I'm going to go back to my programmer hat and put that on. And, you know, you can skip this part if you don't care. And that's fine. And I'm just going to say programmer. So programmer part. Okay, here's the problem. Here's the timeline of your game with time going to the right. And what we're doing is we're saying here, I'll even mark some of these. So let's say this is 1, 2, 3. These are seconds. Let's say that every 0.5 seconds exactly, your service runs. So it's going to run like this, right? And so on. Now, let's say that that's the default, and that's fine. So you just leave it at the default. Now let's say that you have 10 services that are all expensive, that are all running at 0.5 seconds. So your performance is going to look like this, right? You're going to get big spikes every half second. So a common thing that you do is what's called amortizing that over frames. So you might do one this frame, one another frame, one another frame. And by having this deviation, you are limiting the chance, especially if you're running at 60 frames a second, you're limiting the chance that you're going to have a whole bunch of services running in the same frame. So that's kind of the idea. All right, programmer hat off. Mostly, you can leave this as the default. Doesn't matter. If you really need it to run faster, you can lower that number. It's going to cost you performance. I would not recommend it. Average human reaction time for, when something happens and a human actually can see and cognitively react to that thing is kind of an eternity when you think about it. So half a second in AI land, who cares? It's nothing. Sometimes even a second. On The Sims Medieval, and even The Sims 4, but it was more apparent in The Sims Medieval, in really bad performance cases, such as running on a lower-end machine in debug mode, we set it up so that Sims would basically, my coworker called it, they looked thoughtful. And so what would happen is they would sort of stop, and they would just think for a minute, and then they would go and do something. And when I say a minute, it was maybe a second at the most. And that's an eternity, that's 60 frames. But it's nothing, you don't even see it. Sims 4 was even better because they had the ability to exit an interaction, but they chose not to until they could actually do something else, which was smarter because, they always looked like they were doing something. So we're still going to do the sequence move to wait. And we have this player. So this should still kind of work. Here now I have a nice drop down. It's sexy. I can choose whichever one I want. It's very fancy. So we still need a decorator here. But we can use a stock one. We can say blackboard. And blackboard base condition is sort of terrible. So we're going to say has target. And all this is going to say is, what's the query? Is player set? That's all this says. We can do other things like if it's set, if it's not set. But in our case, we're going to say, is the player set? If the player has been set, if this is a non-null variable, if it's been set at all, then this succeeds. Otherwise, it fails. Play. So he immediately goes to me, and you can kind of see what he's doing. Now, if we watch for a little bit, notice how it just flashes back to move 2. And that's what I'd expect. So if I run away now, I should be far enough away that he's not going to come after me. And off he goes. He left. So that basically works. Now if I get close enough again, eventually there he goes. So now he's going to come. And then he stops. He's not really chasing me, but he kind of comes after me. And then he'll leave. So what's happening is we can actually even kind of watch this if we want to. There's nothing super fancy here, but this is the branch. And every half second, this guy will run. It would help if I had him selected. There we go. So he failed. Notice that it's pulsing about once every half second. Now if I go here, he sees me. Oh, now he doesn't. Now he does. And now he's coming after me. So, you know, as I said, this doesn't quite work because it doesn't feel good. The vast majority of AI is really about feel more than anything else. This doesn't feel like someone who's really chasing me. In fact, I can run up to him. I just have to catch him right at the moment when his wait ends. And that does not feel good at all, right? That feels sort of terrible. So the question is, you know, can we do anything about that? You know, the one of the big issues with behavior trees, this is a huge issue with a lot of behavior trees, is how do we manage this sort of thing? So let me go back to the behavior tree, because while he's waiting, I can't interrupt that. That's a huge deal, right? I can't interrupt him. I just have to kind of get him in that spot. If I'm over here, there, now he's waiting. If I can run all over here, he's just never going to see me. I mean, he should, like, interrupt what he's doing, but he's not. So what can we do about that? We could just remove the weights. I mean, that would be one thing. And that's okay, but that's kind of hacky. Furthermore, there are times where we can't have no wait. What if this is a sequence of patrol points? And so I do a move to wait, move to wait. We want to be able to interrupt this wait. So it's not even just like remove the wait and the oscillation is bad. There's other issues on top of this. So how do we handle that? Well, we handle that through observer notifications. And these get really, really complicated. But the basic idea is if I click on any any decorator, I can look over here and I can see different ways that this guy can basically bail on things. And so it's like a sneaky little decorator thing that we can do. And I'll briefly show it, and that's kind of, I think that's where we'll end. So what is it? Notify observer and observer aborts. These are the things. So we're not going to worry about notify observer, but observer aborts. Right now it's none. You have three options. You have self, you have lower priority, and you have both. So none is preferred unless you need it, because it's the cheapest. It's purely event-driven. So it's the best performance. But if you need it, use it. Go to self. So notice that these nodes turned green. What that means is, so it's just showing you which nodes are affected, and if I kept going, you'd see all these other ones. This blue thing, this decorator is evaluated during sort of all this time. If this decorator ever fails, it will abort any of these things and fail this whole branch. And it's a selector, so then it'll move on to the sequence. So if at any time this becomes true, or sorry, if this becomes false, at any time it will bail. Whereas if this is not set, if I go back to none, as soon as this sequence happens, as soon as I run any of these children nodes, it will absolutely go through the sequence. The only way to cancel is one of these nodes failing. Whereas this decorator setting this to self lets me say, okay, this, you know, the effect is going to be, we'll do it in just a second, right? The effect is going to be, right now, let's walk through it very briefly. right now what happens, where are you? There you are, is he comes to me and then I can run away and he's just going to stand there, right? He's going to stand there and then he'll go away. So he'll wait the full 5 seconds. That's the current implementation. If I go here and I set this to self, as soon as I'm out of range, he'll bail. There. He bailed as soon as I was out of range. Come on. Come on back. Oh no, I have to get him to chase me. Come on back. Oh. Hold on. So I'm going to try and get him to... Come on. Follow me. There we go. There we go. Okay, I want him to go kind of far. Okay, ready? 1, 1,000. 2, 1,000. 3... See, he went back. So... after a couple of seconds... So, and remember, the find target is running every half second. So it lets me say, screw this. I'm just going to abort the rest of this branch. And it only works here. So if I go back here, let's watch... There, he did the move too. I mean, I can run here. He's not going to abort that at all. He's only going to abort self, which is anything below him. That's what self means. And it colors it. And older versions of Unreal didn't do that. It was a great thing that they added. Lower priority, notice how it colors these things blue, says, I will abort lower priority things. So in other words, these nodes will fail or succeed or whatever if this changes. It'll bail out of this. It'll basically abort this node and rerun this tree. So in our case, what's going to happen here is it'll bail that wait if I get close enough. Now here I can run away and I have to wait the whole 5 seconds because it doesn't abort self anymore. So he can just sit there and wait. I'm going to wait until it flashes over to the move to. There we go. So now I'm going to go over here. He immediately follows me as soon as I get close, or within half a second because of the find, right? As soon as the target changes, bam, he's right on me. So that's what that does. So it'll abort anything in here to say, oh, we want to do this again. It lets us rerun this part. Now in our case, we want both, which is why there's a both option. So now it does both. So now this, and I'll pull this guy in here and I'll minimize this so we can see a nice big screen. He does exactly what we want, right? As soon as I go away, he's going to go away. Now he's going to chase me. Come on. And then I'll stop and then I'll run away. And as soon as I get far enough away, he's going to go. He'll wait for a little bit, but as soon as I get too close, he comes after me. So that's what that is. It's a little complicated, but it's a very cool and very important tool that we need to add to our arsenal. So this video, we've learned about how services work and kind of how to write our own services with this find target stuff. And we learned about these observer abort dropdown. These are 2 very important tools in our toolbox for building this AI. So with these videos, you should have a pretty basic idea of how to make stuff work in Unreal and how to make this stuff go. The one thing I haven't gone over yet is custom tasks, which you will definitely need to do. In the next video, I want to go over those custom tasks. And this one's getting kind of long, so I'll cover that in the next video. And that's about it. Once we go through some of that stuff, then I want to get a little more high level and say, how do we really make a decent AI with these tools? So that, I've gone through just the basics. I think it'll be really important for us to dig in and say, okay, let's actually make something decent. And we'll make like a little kind of Metal Gear Solid style thing. And that'll be fun. And then we'll drop that into a big kind of not super big, but like a decent sized world and watch how they all interact. So we'll have patrolling enemies who will like see you and raise alarms and all this other stuff. And there's tons of things that's going to bring up, but it's going to be relatively simple. So that's it. I hope you enjoyed that. Let me know if there's anything else. If you have any comments or feedback or anything like that, leave them in the comments, all that fun stuff. And I'll see you next time.